Imagine looking up at the night sky and seeing not one bright object, like the moon, but two. One is our familiar moon, and right next to its orbit, a new fast, moving light appears. An interstellar visitor called 3I Atlas, passing as close to Earth as the moon itself. No telescope needed. No imagination needed, just a real visible object from another star system sweeping through our sky at a distance of only about 384,000 kilometers. In this video, we're going to explore exactly what that would look like, how dangerous it would really be, and how it could change our understanding of the universe. We'll start with what 3I Atlas actually is, then scale the Earth-Moon distance, then drop our interstellar rock into that space, and follow what happens in the sky, on Earth, and in science. First, a quick reminder, 3I Atlas is our third confirmed interstellar object, after Oumuamua and comet Borisov. Its orbit is hyperbolic. That means it came from outside our solar system. It's not bound to the Sunday, and it will only pass through once before vanishing back into deep space. Right now, it's just one more faint dot of light for astronomers. In reality, 3I Atlas is not predicted to come anywhere near as close as the moon. What we're doing here is a controlled what-if experiment, keeping its size and speed realistic, but changing just one thing: its minimum distance from Earth. Instead of missing us by millions or tens of millions of kilometers, we'll make it pass at roughly the moon's average distance, about 384,000 kilometers from Earth's center. So the question is, if an interstellar object like 3I Atlas passed that close, what would we actually see? And should we be terrified or just amazed? Let's start by imagining the setup. We'll assume 3I Atlas is a relatively small interstellar object, on the order of a kilometer across, a mix of rock and ice, similar to a large comet nucleus. It's traveling at something like 50 to 60 kilometers per second relative to the Sunday, comparable to what we expect from interstellar visitors at the moon's distance. That size and speed are enough to be spectacular, but not enough to tug the Earth around gravitationally in a huge way. The moon itself, much bigger and more massive, already sits at that distance and shapes our tides. 3I Atlas, even at the same distance, wouldn't come close to matching the moon's gravitational pull. But that doesn't mean nothing interesting happens. From the ground, the show would start well before closest approach. As 3I Atlas enters the inner solar system, it heats up. Ices near its surface sublimate, turn directly from solid to gas, and carry dust away, forming a faint coma and a developing tail. Weeks or months before the close pass, astronomers would spot it as a slowly brightening speck in the sky, moving against the background of stars. News headlines would explode. Interstellar object, headed for record breaking close pass. 3I Atlas to fly near Earth at moon-like distance. Telescopes worldwide would lock on. As it nears its closest point, it would become visible even to the naked eye from dark locations. Its brightness would depend on exactly how reflective it is and how active its cometary behavior gets. But at moon distance, a kilometer phase-scale object with a bright coma could easily become one of the brightest things in the night sky after the actual moon and maybe Venus. Imagine walking outside on a clear night. There's the moon, and a second, fuzzy pups, pseudo-moon nearby, slightly off to one side, moving a bit each night. It wouldn't be disc face-shaped like the moon, more like a bright star smeared into a small glowing ball with a faint tail pointing away from the Sunday. In the days leading up to closest approach, that motion would speed up. Each night, you'd notice its position shifting relative to the stars and the moon. Social media would fill with time-lapse videos of its rapid march across the sky. For most people, this would feel less like an apocalypse and more like a once in civilization light show. What about the physical effects on Earth? The first thing people might worry about is gravity. The moon causes tides. Would a kilometer phase-scale interstellar object that close cause some kind of catastrophic tidal wave? The answer is no, and the reason is simple. Mass: the moon is about 3,500 kilometers across, and incredibly massive. Compared to a 1 kilometer rock, its gravity is strong enough to tug Earth's oceans into tides that rise and fall every day. In contrast, 3I Atlas at the same distance would be so much less massive that its gravitational influence on Earth would be essentially negligible. The numbers are dramatic. The Moon's mass is on the order of 7.3 multiply 10 power 22 kilograms. A 1 Fe kilometer object, even if its dense rock, might have a mass closer to 10 power 22 or 10 power 13 kilograms. That's a difference of 10 trillion times or more. In terms of tides and large face-scale gravitational effects, 3I Atlas would be invisible compared to the Moon. No extra tides, no shifting of Earth's orbit, no ripping the planet apart. So if it's not the gravity we have to worry about, what about impacts? At Moon distance, 3I Atlas misses us by a huge margin in absolute terms. Hundreds of thousands of kilometers. But a close pass like this can still have interesting side effects. As it sweeps past, outgassing from its surface will throw off dust, ice grains, and small particles. These form a trail along its orbit. If Earth's path ever crosses that trail in the future, we could see a new meteor shower. Tiny specks from an interstellar object burning up in our atmosphere, flashing across the night sky. Some of that dust could settle into new orbits in the inner solar system, gradually spreading out. Over time, we might be able to trace meteor streams back to this one close pass, turning 3I Atlas into the parent of an interstellar meteor shower centuries or millennia from now. But the odds of a large fragment peeling off and actually hitting Earth during the pass are extremely low, especially if the trajectory doesn't bring it physically closer than the Moon's distance. Space at that scale is mostly empty. The Moon itself would have a much higher chance of being struck by a fragment than Earth would, simply because it's closer to the path. From a pure safety perspective, then, a Moon Fe distance pass would probably be considered safe. No global disaster, no strong tides, no guaranteed impacts. It would be a near miss in dramatic terms, but not in the sense of a bullet grazing your skin. Where things get truly interesting is not in what this does to Earth, but in what it does for science and for our picture of the galaxy. Right now, one of the biggest frustrations scientists have with interstellar objects is how little time we get to study them, and how faint they usually are. Oumuamua and Borisov were challenging targets, quickly moving and never very bright. A pass at Moon distance would change that completely. At 384,000 kilometers, even a small object can be studied in astonishing detail. Radar observations, the same kind we use to map near-Fe Earth asteroids, cooled resolve surface structures. We could bounce radio waves off 3I Atlas and get detailed shape models, spin rates, even clues about its density distribution. Optical telescopes could capture high Fe resolution images of its surface, revealing craters, fractures, jets of gas, and maybe even layering that tells the story of its formation around another star. Spectroscopy would let us measure the exact mix of ices and minerals, comparing them to solar system comets. Is interstellar ice different? Do other planetary systems have similar chemistry to ours? If we were technologically and politically ready, a Moon Fe distance pass might even be close enough to attempt something more daring, a rapid Fe response mission. A small spacecraft, launched as soon as we know the precise trajectory, could perform a high Fe speed flyby, skimming just tens or hundreds of kilometers above the surface. A fleet of tiny CubeSats could be released to take images, sniff the gas, and maybe even attempt a sample return, grabbing a tiny piece of matter from another star system and bringing it back to Earth. Suddenly, instead of just watching a bright dot drift by, humanity would be pulling physical material from another planetary system into our laboratories. We'd be able to directly test ideas about panspermia, planetary formation, and the diversity of chemistry in the galaxy. Even without a mission, the psychological impact of seeing an object from another star pass nearer than any other known natural interstellar visitor would be enormous. For many people, it would be the first time they truly felt, not just understood, that we live in a galaxy full of other systems, and that pieces of those systems sometimes come very, very close to us. So let's summarize what a Moon Fe distance flyby of 3I Atlas would actually mean. Visually, it would be stunning. A bright, fast Fe moving, possibly comet-Phae-like object moving through our sky for days or weeks, rivaling the brightest stars and perhaps even giving the moon some competition in the public's attention. It would be a once-Phae species sky event, something people would tell their grandchildren about. Gravitationally, it would be a non-Phae event, despite the scary closeness in space terms. Its tiny mass compared to the moon means no extra tides, no axis shifts, no global quakes caused just by its presence. The danger of a direct impact would still depend entirely on its precise trajectory. At a true moon distance miss, that danger is essentially zero. Scientifically, it would be a gold mine. The proximity would let us study an interstellar object in far more detail than ever before, revealing its structure, composition, and possibly its internal makeup. It could inspire new missions, new telescopes, and a new focus on catching the next visitor early enough to do even more. And philosophically, it would be a reminder that we are not an isolated island. Our solar system is porous. Things come in from the outside and pass very close to home. Each of them carries, in its atoms and ices, the story of another place and time in our galaxy. If this journey helped you picture what it would really mean to have an interstellar object pass as close as the moon, not as an end-Phae world threat, but as a breathtaking near miss and a scientific opportunity, consider subscribing to the channel. I'm building a whole series of realistic what-if scenarios around 3i Atlas and other visitors from deep space. Tell me in the comments, would you go outside every night to watch 3i Atlas fly by? Or would you be too nervous knowing an interstellar rock was that close? And if we could send just one kind of probe to meet it, would you choose a radar mapper, a camera swarm, or a high Phae risk sample return? Because this story can always go one step further, we've just imagined 3i Atlas passing at the moon's distance with no collision. But what if, next time, an interstellar object cuts that distance in half, or even threads the needle and flies between Earth and the moon? In a future episode, we'll explore what happens when the next visitor comes even closer, and how close is too close for comfort.